Well, today is nice because it is a summary, as you can see. And what that means is we're not actually learning anything new. We're taking a day to practice a bunch of things that we already know. But it's nice too because this page that we're looking at right here is a really good summary of what we've been doing over the last, several weeks. And just because we're not technically learning anything new, that doesn't mean that it might tie some things together for a lot of us and reaffirm some hopefully things that we kind of already know, remind us of how to do different things. I am going to go back over, although briefly, a lot of the stuff that we've already done. Okay, so keep that in mind. And this is a page that's really good to hang on to. It I'm going to scribble on it, and you probably do the same. You want to make sure your scribbling is meaningful and legible, so you don't want it to get in the way of the information that's on there. But it's supposed to help summarize how we can find the important information from each of these four representations. So that's what you want this sheet to communicate to you, and then you can hang on to the sheet, pull it out whenever you're stuck, use it over the next few days while you're continuing to work on this stuff and practice this stuff. And any of the four ways that maybe you're not as confident with, maybe this is one page that can help you with, sort of what you need to keep moving forward. After today, we're going to continue to practice with more of the same kind of stuff. We're going to add little bits and pieces of language and ask the question in some slightly different ways. But as I've been saying for a long time now, it still always comes down to those two important pieces of information, which are how much for zero, or the start, or the initial value, and the change, or the rate, right? We really started calling it how much for zero, or where does it start, and what's the change. And we've sort of moved to calling it the initial value and the rate, but they all mean the same thing. So that's something you want to keep in mind, that they still just mean the same thing. And that can take some getting used to, is the different words we use that mean the same thing. Okay. So you'll see this sheet is broken up into two parts. The top part is the initial value. So it's all of the four representations, right? That's what the title says here, and that's what we've been talking about all the time. And one of them is the graph, one of them is the table, one of them is the equation or the rule, and the final one is with words. So we have one of each, 1, 2, 3, 4. And what we want to do in this top part is, from each of these, from the graph, from the table, from the equation, from the words, how do I determine what the initial value is? Okay, so the top part is for the initial value, and the bottom part is for the rate of change. And again, it has one of each. It has the graph, the table, the equation, and the word. So we're going to go over each of these, and that's going to be the entire lesson, and then we'll have some practice to do after that. So for initial value, how do I find it in a graph? When somebody's guiding you to do it, it's really easy. It's remembering all of the stuff yourself that maybe is tricky. So what is it when you are looking at the graph? It's just that point where the graph starts, right? So wherever the graph crosses this vertical axis, if the graph started here and went up, that wouldn't be helpful. We'd have to follow, or if it started here and went up like that, wouldn't be helpful. We'd have to follow it back. Now, we don't really do that, so we don't have to worry about it. But just to be clear, it's not just where your line starts, it's where the graph would start, which is how much for zero. And this is where the zero is, right? So I'd have to follow it back, okay? But that's not something we really have to worry too much about. So in this case, it's where the graph starts, which is at 20, okay? So the initial value, or the start, would be 20. And that's all there is to it. We're just focusing on that initial value for this top part, and so we'd be done. Again, I don't want to jump around too much. I want to focus on what we're talking about, but I will say this. Often when we're doing these questions, we get overwhelmed with the bigger picture, and we look at a line and we go, I don't know what that line means. But if you break it down, you say, well, hold on. I only need two things from that line. One of them is, where does it start? And the other one is, how is it changing? And well, we just found half of that because we just found the start, and it was that easy. Just where does that line begin on that vertical axis? Okay, and that's something that everybody can do. You're literally just pointing to it and reading it off the scale. And so that really helps when you can take a bigger picture, a big problem, and break it down into small parts and start managing those parts. It makes it makes all the difference in the world, right? It allows you to solve a problem that otherwise seemed too hard. So keep that in mind. If you're ever feeling overwhelmed or ever getting stuck, well, hold on, let me slow down. One of the things I have to do is figure out where it starts. Maybe I can just do that. And if I can just do that, that's the first step, and maybe I can continue. Okay. So again, that's why this is really useful, is because it reminds us that we separate finding that starting value from finding that rate. They're two separate things. Okay. Okay, so that was graph. How do we do it in a table? Well, it's just where this is 0, right? It's always the left column. And we'll notice this graph isn't actually labeled this way, but this would be the C and this would be the N. Okay, and they're the same as those ones, right? And so the one on the left is always the one that goes across the bottom, the horizontal axis. And I look for where it's 0 and I find that value. So again, in this case, the start is 20. For all four of these, it's actually the same situation. They do match, or they should match. You can see at 10, I'm at 40, and at 20, I'm at 60, right? So they are actually the same situation, but that's how I would find the initial value or the start from a table. I just look at where the 0 is, and I go across to figure out what the value is where it starts. But we know that it's not always that simple, because sometimes it doesn't show you that, right? Sometimes it's got that blanked out like that. And I have to figure out what the change is and then track back. But for this, we're just worrying about exactly where you see it in a completed table. And hopefully we've done enough practice where we're confident in how to look for the change and track it back if we need to figure out what the 0 is if it's not given, okay? But again, from a graph, it's just where does the line start, and from a table, it's where is the 0 value on the left, but the start is the corresponding value on the right. In an equation, well, I can see this equation. I can see that it has the start, we already know it's 20, is right there. But again, this is what we've talked about all the way. It is the number that doesn't have a variable beside it, because the variable, in this case n, changes. And if n is 1, then this whole thing is 2, because 2 times 1 is 2. If n is 2, then this whole thing is 4. 2 times 2 is 4. If n is 5, then this whole thing is 10. 2 times 5 is 10. So this part of the equation, changes. If n is 5, this part would be 10, and I would have 10 plus 20 equals 30, right? And that would be the total, would be 30, because 10 from here and 20 from here. And what we notice is, something we've noticed is, the 20 is the part that doesn't change, right? It's always just 20. This part changes depending on what n is. So that's the change. This part does not. It's fixed. It's the starting value. It's the initial value. It's how much for 0. I mean, that's the other way you can think about it. If I put 0 in for n, 2 times 0 is 0. That whole part is gone. And this is what we start at, right? But it's probably easier to just remember it's the number without a variable beside it, because if it has a variable beside it, it's going to change. So the start is 20 there. And don't forget, I could write it like this. 20 is still the start in that case as well. Okay, so that's how you get it out of an equation or a rule. And how do you get it out of words? Well, it's going to be a bit different depending on how it's worded, what it's talking about. Sometimes it'll say initial cost, sometimes it'll say fixed. We've used the word start. Okay, so those are all different words that might be used. The admission fee, we've talked about that, how much to get into the park, right? like the original emission fee or something like that. So it can look a little bit different, but it is the part that's not changing. It's a one-time cost. It's an upfront cost. Sometimes we call it the upfront cost, right? It has all these different words, and it's the amount that doesn't change. So in this case, we use the word initial, okay? And again, that amount is 20. The other way you might think about it is probably the question is going to have two numbers in it, and one of them is going to be the initial value, and the other one's going to be the rate. And the rate can be found out, or can be recognized by the word per. So $2 per ride means this cost is going to change depending on how many rides you go on. More rides means more money. More rides, this will still be $20 no matter what. It doesn't change. The total cost changes, but the initial cost doesn't change. So I might decide, wait a minute, this is the rate because it says per, which means it's not the initial value, which means the other number is the initial value. That might be another way that you sort of think about it, or at least confirm for yourself that you've got the right one as the starting value or the initial value. Okay, so there you go. There you have it. There's all four representations of a linear relation, and that's how you can determine the initial value from each of the four: graph, table, equation, and words. And again, this is something we've already done, right? This isn't new. We're summarizing it. We're just reviewing this, but it's not new. We've already done it starting from each of these four things, okay? So that's initial value. Let's take a look at rate of change. Rate of change, I would say, is the trickier one. Uh, Usually, it requires a little bit of work, okay? So let's take a look at the graph first. Now, the first thing that I'm going to do, or that I'm going to think about, is how I can't get it from one point. I need to use 2 points. I don't have to use points that have dots on them. Sometimes we have lines that don't have any dots. Often we have that. Let's see, this one had that, right? No dots. If I was doing the rate, I would just make 2 of my own dots and make sure they're good points, that I'm not estimating or guessing at what they are, that I know exactly what they are. So for example, this point is 140, right? But this one has dots on it. I could use the starting one, even though there's no dot there. That's often an easy one to use, so I could add a dot and use that. I'm going to use a couple that are given, and I'll use this dot, and I'll use that one. Okay, and so how do we do it? Well, I figure out where this dot is across here, and it's 10, and I figure out where this dot is across here, and it's 150, it looks like, because this is counted by 50s, 50, 100, 150, 200. Okay, and for the other one, I follow it down, and I see this is 30, and I follow it across, and I see that this is 250. That's where it is. Okay, so if it's not on the scale, if it's not one of the actual scale values, then I have to figure out what its value actually is. So this one is down here at the bottom, goes from 10 to 30, and here on the side goes from 150 to 250. Now I need to figure out the change of each of these. Well, 10 to 30 is up 20. Now how do I figure that out? Well, I could use my calculator, and I would go 30 minus 10, and that's 20. And I did the bigger one minus the smaller one, but it's a little bit dangerous to always do that. So I am going this direction. So I want to think, is it getting bigger or smaller? And so if I'm going this direction, I'm definitely getting bigger, because 10 to 30 is getting bigger. So that's why I know I'm adding, and the difference is 20. I can get that from my calculator. Even if I go 10 minus 30, my calculator is going to say negative 20, but I know I got bigger, so I want to use a plus. Okay, and we know sometimes these go up and sometimes they go down. So we can also think about whether the change is going up or going down just by looking at the graph. Okay. Okay. And what about this one, 150 to 250? Well, what is that a change of? That's a change of 100. So that went up 100. Again, it changed from 150 up to 250, right? This line is going up. Now, neither one of those things on its own is the change. This is the change in cost, if this is about cost, and this is the change in hours, if this is about hours, but it's not the change of the relationship. So to find the actual change or the rate, I have to do the vertical change always divided, here I'll show it like this actually, divided by the horizontal change. Always, always, always. Do that on my calculator. So my rate is 5, okay? Not 20 divided by 100. Again, not because you're always doing the bigger divided by the smaller. That's not the reason why. It's because you're always doing the vertical divided by the horizontal. You can get decimals that are a change, absolutely. Like this would be 0.2 if you did that division, and there's nothing wrong with that being a change. It's not the change of this graph, but it could be the change of another graph. But the reason why is because we always do the vertical divided by the horizontal. Okay. So that's for a graph, and as you can see, there's a little bit of work. I got to figure out the change here, figure out the change there, and then do the division and get a sort of simplified number answer for that, right? And often it's dollars per hour or something like that, or dollars per class. It has some kind of meaning that hopefully we can make sense of as well. For a table, I do something quite similar, but the entries of my table are kind of like, very much like the dots on the graph, okay? It's the same idea. So I'm looking at the change here, plus 50, and I'm looking at the change here. Now, actually, what a lot of people did, let me get rid of this and let me go back. So that was up 50, and this again is up 50. And in the learning goal, if you remember, what a lot of people did is they just said, so the rate is 50 because that was the change. And the first few examples we did like this a long time ago did look like that, but that's because this was just going up by ones. Then we looked at what happens if this is going up by more than one. So this is going up by 10, and this is going up by 10. And what happens then? Well, that's a change of $50, let's say, for 10 hours. $50 in 10 hours is $5 per hour, right? It's not $50 per 1 hour, it's $5 per 1 hour. And that's the number that we want. We want how much for one. So we have to figure out this change and this change, and then do the division to get the final rate that we're looking for. And again, it's 5 because these are actually the same situation, the same relationship represented by a graph, a table, and then we'll look at what what it looks like as an equation and what it looks like as words. Okay, so I think it's interesting to look at how how these are similar. Looking at the change in a graph is similar to looking at the change in a table. And if you can notice that, then it will help you be able to be good at both. Okay, in the last two parts of this, well, we talked about from an equation from the initial, and we talked about how the initial value is the one without a number or a variable beside it. So that means the rate is the number with a variable beside it. And we talked about why, because n can be 0, 1, 2, 3, 5, 100. It can be like n can be anything, right? That's why it's a variable, because it can change and we can plug whatever we want in for n. And when I plug something different in for n, it makes this whole thing different, and it's changing, and that's why we call it the change. Okay, and so that makes the number out front of it the rate. So that's that's all there is to it. When you're looking at a linear relation, you just find a number that has a variable beside it, and that's your rate. Finally, we kind of talked about this too, because I mentioned how you can tell what the rate is, and then you know the initial value is the other one. And how do you know what the rate is? Because of the word per. And once you see how much per class or each class, or that's when you know that you're looking at the rate, because it says per class or for each class or something like that. Okay, so there's your rate. It's the number that that has a per with it, or an each or something like that. And the other one will say fixed or initial or something like that. And that's it. So we've looked at all four from a rate: words, equation, table, and graph. And we've looked at all four from the start to the starting value. Words, equation, table, and graph. And so your practice for today is going to look very similar to what we just did. Whoop, let me scroll up here and take a look. Here's our practice, and there's going to be 4 examples, and everyone gives you something different to start, and you have to come up with the other 3. So take a look. This one starts with words, and you have to come up with the equation, the table, and the graph, right? And probably the first one you come up with is going to be the hardest, and then from there it'll be easier to come up with the other ones. So example 1 starts with words. Example 2 starts with the equation. For this one, you have to know how to find the rate and the initial value from the equation, and you have to know how to turn the rate and the initial value into a table, how to turn the rate and the initial value into a graph. For this one, you're starting with words. You have to find the rate and initial value from words and turn it into the other 3. So you're getting practice from each of the 4, starting from that and and completing all 4 of them, right? Start from all 4 and complete all 4 on your own. So for one like this, you have to come up with your own words. Now that's something we haven't really done yet, but just be creative, make it whatever you want. C can be cost, N can be number of something, but it doesn't have to work that way. It can be whatever you want, right? Use the examples that we've seen. We've seen a lot of examples already. Use ones that we've seen to inspire you, to give you an idea if you're stuck. But if you think you get this and you want to be creative, that's fine. Just don't be so creative that what you're saying doesn't make sense. It's important that it's correct as well and makes sense. So it might help to look at some past examples of words in order to do that. I mean, there's one right here, or there's the 2 in the summary that you could think about and use as a model. Okay, that was example 1 and 2. Example 3 starts with the table, and you have to come up with the other 3 representations. And example 4 starts with the graph, and you have to use that to find the initial value and the rate and come up with the other 3. So lots of practice coming up with all 4 of the different types and practice of each type starting with it. There is, well, it's not called example 5, but there is one more blank one, and you'll notice it has none. None of them are filled in. And so this is meant to be a chance for you to make up your own. Usually what we do in class is you make one up and pass it to a friend, and they fill out the other 3, and you can sort of exchange. They can do one for you and you exchange. If you don't have that option, you can make one up yourself or have somebody around make one up for you. Maybe they come up with a table or something, but if they're not taking this course, they may just come up with a random pattern and it doesn't make sense, so be a bit careful of that. Or you can just come up with your own and then fill in all 4 of them for your own example. Okay, but if you can do the first 4 examples, starting from each of the 4 and moving to the other 3, that's fantastic. Again, that's what today is all about, a bit of review of each type and hopefully kind of solidifying the whole situation for us.